Jól van. Szia. Szia. Hello YouTube, this is Capandball here again. I have a beautiful rifle for you today. This is a model 1842 or 1844 Kammerbüchse or chamber rifle from the Imperial Royal Army of Austria. And this is a quite important rifle in firearms history, as it has a smaller caliber chamber in the breech, which was supposed to hold the powder charge, and the bullet was hammered on the mouth of this charge. But how, I will tell you later. This is quite an important part in firearms history, as this was a first step towards the conical bullet. So this is why it is so important. You may also know this rifle as the Garibaldi rifle from the American Civil War. It's a model 1844, and also the model 1849 version was used in the American Civil War, and it was not really loved by the troops because it had a much larger caliber than the Springfield rifles or the Enfield rifles or the later Lawrence rifles. The smaller caliber powder chamber in the breech of the rifle was invented by Henri Gustav Delvigne, a French captain, who was working on this concept from the 1820s, the second half of the 1820s. Let's learn a bit about the history of this chamber rifle. But before we do so, let me thank you for your support. Your donation through Patreon, buying our authentic American Civil War cartridge boxes, or our percussion revolver cartridge formers, or our US Arsenal Stadias or rangefinders, or our rubber printing plates, or our powder measures made according to the Ordnance Manual of 1841, they all help to keep the quality of our channel high. Without you, this would be much difficult. So thank you very much again. The French army was fighting a war against the natives in North Africa. They faced an enemy that was avoiding open field battles, which avoided hand-to-hand combat, and always kept a distance. They needed a different tactical approach than the regular and light infantry tactics of the Napoleonic Wars. And they also needed a better arm. They needed something that can reach further than the smoothbore musket. This was the time for the rifle.
The infantry tactics were still based on the close combat formations like the deployed line, the column, and the square, and open formations like the skirmish line. Nearly all European armies developed its light infantry from the early 1800s, but the French army was reluctant to arm the soldiers with rifles. The North African campaign changed all this. The irregular tactics of the natives required a rifle that can reach far and still had the same rate of fire as the smoothbore musket. Delvigne was born in 1800 in Hamburg. He had several important military inventions that earned him high decorations. In 1830, he left the army after the July Revolution. His great patron was the Duke of Orléans, Louis Philippe, a great supporter of the rifles and the regular light infantry. In the second half of the 1820s, he was working on his method to speed up the loading of the rifles. He constructed a smaller caliber chamber in the breech of his rifle in 1826. The undersized ball was loaded without a patch. It rolled freely into the breech and had to be hammered with a heavy ramrod to upset it into the rifling for a tight fit. The solution was good, but not perfect, as the accuracy depended on the symmetric and uniform compression of the ball. His solution was adopted by the French army in 1842.
Let's check now the development of the Austrian Kammerbüchse rifle.
By the end of the 1830s, increasing the ratio of the rifle in the Imperial Royal Army became more important. But not even the Jaeger troops were armed entirely with rifles. Only the third row had 13.9mm Jägerstützen short rifles. The first and the second were armed with smoothbore Jaeger carbines, a shorter version of the standard infantry musket. Feldzeugmeister Vincenz Augustin, head of the Viennese arsenal, developer of the tube-lock percussion system, was a great supporter of the rifle, so he understood the benefits of the Delvigne system. He made some important improvements to the original chamber system. The original chamber had sheer walls. Augustin rounded the sharp shoulders of the chamber to achieve a more even expansion of the hammered bullet. The rifle was put on trial at various Feldjäger battalions, and based on the success of the tests, the Emperor finally ordered the acceptance of the new rifle for the first two rows of the Jaeger troops in 1844. According to contemporary sources, in 1845, a Kammerbüchse was fired 20,000 times without cleaning or malfunction. The production started with converting 47,000 old war-booty French musket barrels from the Napoleonic Wars. This is why the caliber of the bore became 18.1mm.
The transition was very slow. In 1848, the Abrichtungsreglement of the Jaeger troops still mentioned three types of Jaeger troops. The first one was the Stützenjäger, armed with the Jägerstützen rifle, the short rifle, which you can also see on my channel. The second type was the Karabiner armed with the smoothbore musket with a bit shorter barrel than the standard infantry rifle or infantry musket. And the third type was the Büchsenjäger armed with the Kammerbüchse. So which means that actually there were three kinds of cartridges that had to be supplied to the Jäger battalions. From the logistics point of view, this is not a good solution. It was not only the Jägers who received this new rifle. The sharpshooters of the border guard regiments also received the Kammerbüchse.
The National Border Guard regiments of the KK Army were a unique military system that provided excellent light troops for the army. A large portion of these troops were armed with rifles from the beginning.
Adopting the Kammerbüchse for the KK Army was a great step forward. But let's not forget that the deep groove rifling of this bore is suitable for round balls only. And in the 1840s, everybody knew that the ballistic performance of the conical bullet is much better than the round ball.
The greatest contemporary competitor of the chamber system was the carabine à tige, invented by Louis-Étienne Thuvenin. He placed the pike in the center of the chamber in axis with the bore. The bullet was hammered on this pike to aid symmetric expansion. Many European countries, including the KK Army, adopted this new system as well.
Okay, now I think it's time to check the accuracy of this rifle with the mil-spec cartridges. So we are going to actually reproduce the original powder load and the original bullet.
The original 1842 model Kammerbüchse cartridge held a 17.74 mm diameter round ball. The Kammerbüchse bore had a nominal diameter of 18.1 mm, so the bullet fit was tighter than in the case of the muskets. The powder charge was 55 Gran Scheibenpulver. This was a very fine shooting powder, which is approximately 3.85 grams today, or 60 grains.
And this is the reason why it is so tricky to shoot the Kammerbüchse, because the group size is depending on how you hit the ball into the chamber. So if you do it with uniform force, then you are okay. Then you will shoot hole in hole at 50 meters, which is very, very good for a rifle like this. But if you don't do it properly, like I did in these cases, I did put the rifle on my shoe, not on the ground. And it did eventually affect the group size. Funny. Let's check now the most important specifications of this rifle.
The barrel is rifled with 12 deep grooves. And when I say deep, I really mean deep. The bore has a half draw, meaning that the spiral turns half turn in the bore. So the twist rate is 1 turn in 62.5 inches. This should be a good choice for round ball. The charge was limited, the bullet was heavy, so the muzzle velocity was low, which means that the new leaf sight had to be installed on the rifle bores. According to contemporary sources, the rifle was effective against an individual enemy soldier up to 400 paces, but on close enemy formations of infantry or cavalry, or against a battery of artillery, it was good up to 800 paces. The length of the bore was 79.3 centimeters. The new rifles were delivered to the troops with notches of the rear sight uncut. The rifles were sighted in a distance at 12 to 15 paces on a target with a black vertical line on it. The rifle was placed on a sandbag, and the front sight was adjusted horizontally until all shots hit the black line. The proper height of the rear sight leaves were set with filing during the test shooting to 300 and 400 paces.
Each and every single Büchsenjäger received a Hau bayonet or sword bayonet for the rifle. This was attached to the bore as a socket bayonet with a Lockhart style fixing system, which was easy to fix and it was very easy to remove. Looks great, isn't it? The equipment of the Büchsenjäger was much simpler compared to the equipment of the Stützenjäger. He did not need any kind of special cartridge box. So the cartridge box was a simple infantry cartridge box without the straps for the ramrod. In fact, the ramrod of the rifle is placed in the stock in his own channel. And also, this cartridge box strap did not have a separate leather sling for the powder measure. The Büchsenjäger was not issued a powder horn, which means that the Büchsenjäger received the powder and the ball as paper cartridges. The standard cartridge of the Kammerbüchse was a really interesting piece, as the ball and the powder container was separated.
The Büchsenjäger armed with the Kammerbüchse received 60 cartridges. The cartridge itself was a blind cartridge holding the powder charge with a percussion tube attached to the paper case with a piece of twisted wire. These cartridges were bundled by 12. The round balls were also packed by dozens in separate packages. The Jäger therefore received 5 from both. When close to the enemy, he had to open 2 packs from both. The cartridges were placed in the main compartment of the box, while the 24 bullets were placed in a small leather bag in the right corner of the box. There was also a very clever way to lubricate the bullets, as there was no patch included in the cartridge. A small piece of tallow was placed in the bag that applied a light coat of lubricant to the ball. The percussion tube was placed under the folded end of the cartridge. This protected it from impact. My round balls are the exact reproductions of the original. The mold was made by Tanner Bullet Molds in England. To replicate the lubrication, I deplued my bullets in pure tallow.
It is interesting that a contemporary, let's say nearly contemporary source, Anton Dolecek, is listing another cartridge for the Kammerbüchse. It is holding the same kind of powder, but it also holds a patched round ball. And the patched round ball is a 24 gram or 15.9 millimeter diameter standard smoothbore musket round ball. I have never ever found any other source for this cartridge, so probably this is just the invention of Dolecek. The loading procedure of the Kammerbüchse was quite close to the loading procedure of the smoothbore muskets, and in fact, the rate of fire was supposed to be the same. I thought I was on the right track when I discovered that if I put the buttstock on my foot, then the group opens up. But I was wrong. There is one more element that I was not caring for, and this is the volume per weight of the original powder compared to the Swiss powder. As a substitute, I started to use 2F Swiss powder, which is in corn size and in composition also, it is quite close to the Scheibenpulver. The only difference is that the Scheibenpulver is much better polished, so if you check the corns under a microscope, you will see that they are much smoother than in the case of the Swiss powder. For this reason, I stepped one step in granulation up with the Swiss powder. I stepped to 1.5F Swiss powder just to compensate this effect. But still, there is one big difference between the two powders, and this is the volume per weight. We know from the manual that the chamber could accept 60 grams, this is 65 grains of powder, from the Scheibenpulver, of course. And we also know from the manual the exact size of the chamber. From these two data, we can calculate the volume per weight of the original powder, which is 0.78 gram per cubic centimeters for the Scheibenpulver. Now if you measure the modern powder, the Swiss 1.5F or 2F powder, you will be somewhere at around 0.9 to 1 gram per cubic centimeters volume per weight, which is a big difference, which means that the modern powders are much heavier than the old powders, which means that when I added my powder, my 60 grains of powder in the chamber, I left an air gap between the bullet and the powder, which is not good. So this is something that I had to fill with filler, like cornmet.
The 55 gram old Austrian unit of powder equals now 60 grains of powder. But the 60 grain Swiss powder measured by weight left an air gap between bullet and powder. This is clearly visible through the endoscope. This gap is what I had to reduce with the filler. This is my second attempt with the new charge, with some cornmet filler above the powder charge. According to the Abrichtungsreglement, a very unique method was used for teaching the proper aiming for the soldiers. A small piece of paper could be attached to the tank with a small aperture on it, to act as a primitive diopter. With this sight it was not hard to shoot cloverleaf in groups at 50 paces.
Tüzérség is itt fog gyakorolni.
Igazi vadászkutya, akkor azonnal kirohan a lövés irányába. Lehet, hogy még nem. Nem az igazi. De hát szerintem a 20-at lőttem meg
Vállalod egy kicsit. És most esik oda felel, vagyis elkezdett lelegőteni, látod, hogy fölle volt a pusolyonkor már csak fölle volt. Looks like we found the Holy Grail. This is 5 shots in the size of the 10 ring at 50 meters, which is very, very good. I confirmed the accuracy of this rifle without any patch, with only this compression method on the bullet. And my charge was 60 grains of 1.5 F powder and 10 grains filler, which was cornmet. Probably you noticed that the ramrod is heavier than usual. It has a very strong head, a heavy head. The tip of the ramrod is countersunk to match the cylindrical shape of the bullet. This will help a good symmetric expansion, and it's also protecting the rifling of the gun with a brass ring on the end. According to the Abrichtungsreglement, the rate of fire of this rifle was the same as the smoothbore musket, which means 5 to 6 shots per minute. And it also stated that the accuracy of the Kammerbüchse was much better than the accuracy of the Jägerstützen. Well, from my experience, I have to say that both data are completely over-optimistic.
First, the Zünder or percussion tube is placed into the pen. Then the lid is closed. The tail of the cartridge is bitten off. The powder is charged in the bore. The paper case is thrown away. The ball is dropped into the muzzle, and then it is hammered on the mouth of the chamber with a harder and a softer stroke.
For a rifle, the key element is accuracy, and with 5 to 6 shots per minute, well, you completely lose accuracy, that's for sure. Battlefield archaeology reads the past from the most common artifact found on battlefields, bullets. This is why I decided to catch a bullet fired from this gun to exactly see what marks the rifling and the hammering leaves on the bullet.
I decided to catch that bullet using an old method I learned from the forensic experts. I filled the box with loose cotton and fired the bullet from 30 meters. The cotton will gently slow down the bullet without deformity. The bullet traveled only 25-30 centimeters in the cotton, and was surprised how nice a mushroom form it showed. The extension seemed to be completely symmetric. The 2 strokes with the ramrod were more than enough to upset the bullet into the rifling. The bullet grew to a diameter of 18.8 millimeters, while its length shrank to 16.6 millimeters. I used a digital microscope to check if the grooves were also filled. Although it is barely visible, it actually did fill the grooves as well.
The bullet of the Kammerbüchse is slow and heavy, and usually slow and heavy bullets are like a freight train. The energy transfer is bad, but the penetration is excellent. Well, this bullet penetrated 2 FBI blocks, so we can prove that. The temporary cavity is moderate. Is of course moderate because the velocity is low. But on the other hand, the permanent cavity is very strong, it cuts a real big hole, and the entrance wound and the exit wound is also large.
High-speed camera footage also proves that the bullet actually seals the gases very well. There is only a very little amount of gas exiting in front of the bullet.
We have a ballistic radar on hand, so we will be able to check how the mushroom form is affecting the outer ballistics of the projectile.
The ballistic radar is an excellent tool. It not just only measures the muzzle velocity, but it also follows the projectile, and it is able to record its speed at various other distances as well. For a historical shooter, this is very important, as these velocities help us calculating the true ballistic coefficient of the bullet for further simulation of the trajectory. This is especially helpful in case of odd-form bullets, like our beautiful mushroom. Now the charge and the loading method is exactly the same as in the manuals. The form of the bullet significantly changes when it is hammered on the chamber walls. This is surely not good for ballistics performance. To get a better view, I decided to fire an undeformed round ball as well, to have a good comparison. So this time I will avoid the hammering, and I will just gently push the bullet on the powder. The muzzle velocity was much slower, which is a good proof of the bad gas seal. The ballistic coefficient, or G1, is calculated with the following formula, where x is the distance between the 2 points where we measure the velocity. In our case, it is at the muzzle and at 50 meters. V0 is the muzzle velocity and the V50 is the velocity at 50 meters. Let's check the mushroom first. The average muzzle velocity of 5 shots was 329 meters per second. The average of the 50-meter velocities was 277.4 meters per second. So the ballistic coefficient of the mushroom is 0.178. Let's check the perfect round ball now. The average of the muzzle velocities was 278.5 meters per second. The average of the 50-meter velocities was 254.5 meters per second. The ballistic coefficient of the perfect ball is 0.290. The bigger this number is, the better the ballistic performance of the bullet will be. So all in all, the mushroom has an inferior ballistic form compared to the spherical ball. So we can be sure that this will have an impact on accuracy, energy and killing power.
Let's check now the accuracy of the rifle at 100 meters.
Majd a balhátlag így kell jönni. 12 óra. Ja, 12 óra a 10-es. Olcsó csináltak a félfóra? Ja.
At 100 meters we are, and if I'm good to myself, I would say that we are in the size of the black area, but I have had some misfires, showing that the rifle is getting dirtier. There are only 36-38 shots now in the rifle, but still it works. The chamber system with hammering the round ball on the face of the chamber was not a perfect solution. The human factor is just too large, which is not good for military use. But, in fact, the Delvigne system paved the way for further developments and paved the way for the conical bullet as well. From the 1840s, Delvigne itself was experimenting with conical bullets and sabots as well. By those times, there was one big competitor for the chamber rifle system. It was the Tuvenin system, which is also a very good concept. I will talk about this later in a further video as well. But these two competitors, they really played an important part towards the conical bullet. So ladies and gentlemen, thanks for tuning in. You've been watching the Capandball YouTube channel. If you like what I do, then please subscribe, comment, share, like. This will help to grow our channel. If you wish to support us, you can do it through Patreon or by buying our products. So ladies and gentlemen, until next time, stay cool and keep your powder dry.